Okay, so this is the Berlekamp-Welch problem. Um, so suppose that the message we want to send consists of 10 numbers. We find a polynomial of degree 9, which goes through all of these um, points and evaluate it on 25 points. How many erasure errors can we recover from? How about general errors? So for erasure errors, let's say we have n is the size, n is the size of the message we want to send. In this case, n is equal to 10 and k is the number of errors we have. That means that n plus k is equal to the number of points that we send. Um, or at least we need to send that many points, right? So that is 25 in this case. So 10 plus k is equal to 25, which means the number of errors we can have is 15. Okay. And in the case of general errors, as opposed to erasure errors, it's n plus 2k, right? And this, the number of points that we send, has to be less than or equal to 25. And you'll see why I'm doing the less than or equal to. It's because we'll get like two, two does not evenly divide 15, right? So 2k is less than or equal to 15. K is less than or equal to 7.5. So basically k is equal to 7 because it has to be an integer. So the number of general errors that we can have is 7 because 10 plus 2 times 7 is 24, which is less than the number of points that we are allowed to send, which is this 25. That's the constraint. Um, yeah. And so now we have Alice sends Bob a message of length 3, right? This message is of length 3, right? Where n is equal to 3, right? So the message is of length 3. And the uh, n plus 2k, this is a general error, right? N plus 2k is equal to 5. We're actually sending 5 numbers here, right? So this is n plus 2k is equal to 5, which means k is equal to 1 if we substitute 3 in there, right? Um, k is equal to 1. That means that there's only one error out of these 5 points that are sent. This corresponds to 1, this corresponds to 2. This one is 3, this one is 4, this one is 0, or maybe 5, based on your interpretation, because it's GF of 5. And yeah, so the error, there's only one of these points that's an error. So for example, it could be 3. 3, 1 could be an error, right? It's not valid. It's like it should be a 2 or something, and right now it's a 1. So that's what we're saying here. Um, but essentially, the way that you attack these problems is you say P of I times E of I is equal to Ri times E of I. Okay, and I'll explain what this means. E of I is what we call the error polynomial, right? And the error polynomial kind of the rule that is that if I is an error, it will when we put it into the error polynomial, it will give us 0, right? Otherwise, we don't care what it gives us. But if it is the error, then it will give us a 0. So for example, here, if 3, 1, this point right here is the error, then if we were to input 3 as I into, so E of 3, for example, would be equal to 0, right? And we don't care about anything else. This is the rule right here. And in order for this to be satisfied, right? For example, we could make our polynomial x minus 3. Because when we put 3 in here, we get a 0, right? 3 minus 3 is 0. So the form of e of x, right? E of x. Sorry, I'm using I and x interchangeably here, but um, the form of e of x is going to be x minus error number 1, right? So in this case, it could be 3. But let's say there's also an error in 2, right? So maybe there's another error, x minus E2, whatever like the second error is, right? And so on. If there are k errors, in general, this would be x minus E1, x minus E2, x minus E3, all the way to EK, right? And if you put any of those errors in, this whole polynomial will become 0. And the logic behind this equation is that if the point is good, if the point is good, then pi is equal to ri. What we received is equal to what is like actual point on the polynomial that we want, right? And therefore both of the sides are equal, right? If the point is good. If the point is bad, then you see here that E will become 0, right? E of I will become 0 if the point is bad, right? The point is bad, this will become 0. And then you'll be left with 0 equals 0, which is also true, right? So the whole point of this is that um, we're going to list out a bunch of equations that take this form, where we're going to, instead of I, we're going to put I equals, 1, I equals 2, I equals 3, I equals 4, and I equals 0. So we'll end up having 5 equations. And here we've specified that the k is 1, right? So specifically, I can make it a little bit easier and just say e of x is equal to x minus b, right? Where b is your, like, whatever actually I'll use maybe e, right? X minus e. E is your error. You only have one error in this situation. Um, but yeah, so this is what e of x is, and you can notice that the degree of this degree is equal to 1, right? Because you only have one error. The degree of, okay, so and q of x, right? Where does that come in? This is q of x. When you do p of x times e of x, I guess I should call this maybe q of I, right? But I'm using it kind of interchangeably. I and x are just dummy variables, right? But here you can see that the product of p and e is q, right? That is the like that's what's happening here, right? P, the degree of polynomial p. So our message is of length n, right? Which means that the degree of the polynomial is going to be 1 less than that. The degree is n minus 1, right? But remember, sorry, I'm going to use a little bit of this space here. Remember, an n minus 1 degree polynomial kind of looks like this: a n minus 1, x to the power of n minus 1, plus a n minus 2, x to the power of n minus 2, plus, all the way to a 2x squared plus a 1 x to the power of 1, which is just x, plus a 0. And sorry for this being a little messy, but these are the coefficients for the polynomial, right? And these are the terms that we're going to be solving for. So the hope is, like, you have 5 equations and 5 variables, and I'm trying to show you that there are indeed the same number of variables and equations, right? Because the degree is n minus 1, the number of coefficients here is actually n, not n minus 1, because you have this a0 at the end. So there's actually n variables. And by the way, this is coming from p of x, right? So there are n variables in p of x, okay? And in an n minus 1 degree polynomial, right? If we were to multiply this by, so we have a n minus 1 degree polynomial, we have a k degree polynomial, right? And if you multiply them out, an n minus 1 degree polynomial and a k degree polynomial, you multiply them out, the resulting degree is just adding those two, n plus k minus 1. But the thing to notice here is that if this is an n plus k minus 1 degree polynomial, the first term is going to be, a n plus k minus 1, x to the n plus k minus 1. Sorry for the messy handwriting. Plus all the way to a1 x1 plus a0. Not to be confused with these ones. I should have probably used a different letter for, like, a. Instead of a, I should have used b or somewhere here. But what I'm trying to tell you is that the number of coefficients here is n minus k. Sorry, n plus k, not minus 1. It's just n plus k, because you have this a0 at the end. Just in the same way that this has n coefficients over here, this has n plus k coefficients, not n plus k minus 1. So there's n plus k variables here. And the other side, has like k variables because one for each of the errors. So this would be one variable, this would be one variable, right? If you have k general errors, you have k variables, right? And so you have n plus k variables that come from, this comes from the q of x. And then you have k variables, sorry, variables that comes from the e of x. And the total number of variables between the two is n plus 2k. That's where the n plus 2k comes from. So basically, you have that many. So how many equations you have? You have like that many, as many as the number of points as you get, right? And we're saying that we're going to send n plus 2k points. So we have n plus 2k equations, which means like that's the number of equations. Um, and that's also the same as the number of variables that we're trying to solve for. And so what you end up setting up is like you have you have five equations, you have five variables, and then you just set this up as a system of equations and you solve, right? So in order to do this particular problem, let's see. So we are I'm going to call it, instead of a n plus, all of this like subscript stuff, I'm going to do like a, b, c, and d, right? And e. So the degree of this polynomial, so we know that from our problem, n is 3, k is 1, minus 1 is just 3. So this would be like a third degree polynomial, right? So I'm going to call this a x to the power of 3 plus b x squared plus cx plus d. And d is like the constant term. Okay. And this is your q of x. Okay. And your e of x, I've already specified here, is x minus e. E is my error. Well, that worked out actually, the lettering of that. So if we want to write this down, we just want to write this thing down literally 5 times for every single point that we have, right? And I'll write it once for the first point, let's say 1, 3. For this point, this is the first point that we've gotten, right? And this is I'm getting it from 1, 3, this thing right here. Okay. So we want to write q of x is equal to r, I guess x, since we're using x, e of x. Okay. And here, x is equal to 1. And r of x is equal to 3. The thing that we got when we for the message of 1 was 3. So here we have if we put in 1, right? We get a plus b plus c plus d, right? That's what you get when you put 1 for q of x, right? For this thing right here. That's that. And then that's equal to 3 times x minus e. Okay. And by the way, we can substitute one more point in just to show you. Let's put in the last point, 0, 1, right? 0, 1. So we have the point 0, 1. Here, x is equal to 0, and r of 0, or r of x, is equal to 1. The thing that we got was 1. So if we substitute that for q of x, you have actually this term goes away, this term goes away, this term goes away. You're just left with d. And that is equal to, oh, by the way, I should have put 1 over that. That should be a 1. And that is equal to r of 0, right, which is 1, multiplied by x, which is 0, minus 3. Sorry, minus, why am I saying 3? E. And from this, you get d is equal to negative e, right? Okay, so we have some information here, and then you would go in and you would substitute that over there. And eventually, basically, you have one equation per point that you have. And total, we have 5 points, so 5 equations. And we have 5 variables that we're trying to solve for, a, b, c, d, and e. And if we just set these up, just list out the things for the other points as well. And then you solve it, you will get E is equal to 3. A is equal to 1. I'm just looking at the answer. B equals 3, C equals 3, D equals 2. So what this is saying, if you solve all of these equations, is that Q of x is equal to, well, let's see, x to the power of 3 plus 3x squared plus 3x plus 2. Okay. And E of x is equal to x minus 3. That's what it's saying. And that's like that's the solution for finding out which one was the error, right? The error was at the 3. And I took that just as an example, but that ended up actually being the answer. So this point right here, 3, 1, that's the one where the error is, right? That's what we've kind of solved for. And let's see. So, okay. And so we have to go back to what is the definition of Q? Q of x is supposed to be equal to P of x times E of x. And this is what we said up here. I believe is here, right? So Q of I equals P of I times E of I, right? So this, but we want to solve for P of x. So what we do is we do Q of x divided by E of x, right? And this is just polynomial division. We have to divide this polynomial by this polynomial, right? And let me just tell you what like the solution is. You end up getting, if you divide these two polynomials, you end up getting x squared plus 6x plus 21 plus 65 over x minus 3. Okay. And then and then yeah, so all you have to do from here is like this is going to be x squared plus x plus 1 because it's mod 5, right? And then in order to find out what the actual message was, all you need to do is substitute, 1, 2, 3, 4, and 0. 0 is the same as 5, right? 0 into this and find out what the message is. And that ends up being 3, 2, 3. So for 3, 2, 3, 1, 1. I think that's the answer, yeah. So that is the actual message that was supposed to be sent. Okay. Thank you.